Have you heard the whispers? They ripple through the internet, across forums, and in hushed conversations. The story goes like this. NASA, the pioneering space agency, supposedly had a quantum computer, a machine of incredible power. And then, something went terribly wrong. A terrible incident, some say, forced them to shut it all down. It sounds like the plot of a science fiction film, doesn't it? A machine so advanced, it becomes a danger, or perhaps it unlocked something best left undisturbed. Quantum computers themselves are shrouded in mystery for many. They promise to solve problems intractable for even the most powerful classical supercomputers. So, when NASA is linked to a dramatic quantum computer incident, people naturally pay attention. The combination of a frontier technology and a leading space agency creates a potent mix for speculation and intrigue. But why does this rumor gain traction? Perhaps because quantum computing feels on the cusp of revolutionizing our world, yet remains just beyond everyday experience. Its principles defy common-sense intuition, delving into the strange world of quantum mechanics. This complexity makes it easy for misunderstandings and misinformation to spread. As we embark on this journey to uncover the truth, it's crucial to approach these whispers with a healthy dose of skepticism. Where did this story originate? What is the actual evidence? And what is NASA truly doing in the world of quantum computing as of June 2025? Let's explore. So, what exactly is a quantum computer? Let's unravel this without making your brain feel like it's been through a black hole. Imagine a regular computer bit. It's like a light switch, either on or off, representing a 1 or a 0. This simple system powers all our digital technology. Now enter the quantum realm. A quantum computer uses qubits instead of bits. Think of a qubit as a spinning coin, neither heads nor tails until you catch it. It can be on, off, or both at once, a state called superposition. This lets quantum computers explore many possibilities simultaneously, offering a colossal advantage for certain calculations. Qubits can also be entangled. If you measure one, you instantly know the state of the other, even across vast distances. Einstein called this spooky action at a distance. This interconnectedness allows quantum computers to perform calculations in fundamentally different, potentially more powerful ways than classical computers. So, a quantum computer isn't just a faster laptop, it's a different beast, operating on the mind-bending rules of quantum mechanics. It won't help you check email faster, but for designing new materials, discovering drugs, breaking complex codes, or optimizing enormous systems, quantum computers hold promise. Designing new materials, discovering drugs, breaking complex codes, optimizing enormous systems, they're tools for the monumental computational challenges at the frontiers of science and technology. That's why the idea of NASA using one is so captivating. But what's the reality behind the rumor? NASA, always pushing boundaries, has been intrigued by quantum computing for years. Their mission demands solving complex problems like planning Mars missions or analyzing massive datasets from space telescopes. These are precisely the kinds of challenges where quantum computation might one day offer a real advantage. NASA's interest isn't new. Researchers have explored quantum principles for computation, sensing, and communication. Imagine sensors so sensitive they detect minute gravitational anomalies or communication systems that are inherently secure. Early efforts involved partnerships with universities and quantum research groups, focusing on optimization problems, finding the best solution among countless options. Quantum annealers, a specific type of quantum computer, were among the first explored for these tasks. This foundational interest set the stage for NASA's more concrete investments as the technology matured. While rumors of dramatic shutdowns circulate, NASA's real quantum journey in 2024 and 2025 is one of steady progress. On July 31, 2024, NASA announced its first-ever quantum memory, developed at the Glenn Research Center with Inflection Incorporated. This device stores information in a cloud of rubidium atoms cooled by lasers, then releases it as photons, crucial for future secure communication. Dr. Adam Fallon from NASA. Glenn sees this as a foundational step, potentially enabling quantum transmission across vast distances, even space. Later, in December 2024, NASA's Goddard Space Flight Center awarded a contract to Quantum Computing Incorporated for a specialized quantum optimizer. The goal: tackle phase unwrapping, vital for reconstructing images from radar data used in Earth and planetary science. This lets NASA compare quantum optimization directly with classical algorithms for real-world challenges. Dr. William McGann, CEO of QCI, confirmed this comparative goal. Such projects help NASA understand where quantum devices offer genuine advantages. Evan Katz from NASA Glenn notes that quantum tech might let NASA explore or sense things impossible with classical methods. These developments show active engagement, not retreat in the quantum field. The reality is far more exciting than any rumor. Let's address the rumor, the alleged NASA quantum computer shutdown. A thorough review of news and official NASA announcements up to June 2025 reveals no evidence of such an event. Reputable sources show ongoing research and strategic adoption of quantum technologies by NASA, no credible reports of shutdowns or disasters. Sometimes misunderstandings about quantum mechanics or routine project changes get twisted into dramatic stories. The gap between quantum's promise and current reality can lead to disappointment or re-evaluation, which some misinterpret as failure. But recalibrating expectations isn't a catastrophe. The real story is one of continued exploration and methodical progress, not retreat from disaster. While the terrible incident rumor is fiction, the path to practical quantum computers is filled with real technical challenges. The biggest is quantum error. Qubits are incredibly delicate, easily disrupted by environmental noise. Current devices, called NISQ machines, are noisy and unreliable for long, complex computations. Quantum error correction is a massive undertaking, often requiring many physical qubits for a single stable logical qubit. Another challenge: quantum computers aren't general purpose. They excel at specific problems, like factoring large numbers or simulating quantum systems. For many tasks, today's quantum computers are actually slower than high-performance classical machines. Data bandwidth, moving information in and out of quantum processors, is also a bottleneck. These aren't insurmountable, but we're still in the early days. Progress is real, but the path to widespread, fault-tolerant quantum computing is a marathon, not a sprint. NASA's approach is to invest carefully and learn as the field evolves. Why do rumors like the NASA quantum shutdown spread so easily? Sensational stories about advanced technology are more captivating than reports of steady progress. Quantum computing's complexity creates an information vacuum, making dramatic, simple explanations appealing. Social media amplifies these stories, spreading them faster than corrections can catch up. Even when debunked, myths persist because the original story is more memorable. Our fascination with the unknown and transformative technology fuels these narratives. That's why it's vital to seek credible sources and separate fact from fiction. Setting aside the drama, the real future of quantum computing for NASA is genuinely exciting. Quantum computers could revolutionize optimization, designing spacecraft trajectories, scheduling deep space communications, or managing lunar outposts. The QCI Dirac-3 contract for radar imaging is a concrete step, aiming to extract clearer information from complex datasets. Quantum communication is another frontier, secure, efficient channels for interplanetary data, enabled by quantum memory. This could transform how we control robotic explorers and support human crews far from Earth. Quantum sensors might detect faint gravitational waves, map planetary fields, or search for biosignatures on exoplanets. As Evan Katz from NASA Glenn said, quantum tech could let NASA explore or sense things impossible classically. These applications are still in research, but they represent a bold vision for the future. The real promise is methodical, not mythical. The story of NASA and quantum computing is less about sudden drama and more about a quiet revolution. There's been no terrible incident, just a dedicated community working to harness quantum mechanics for space and Earth science. Progress is slow, requiring patience and significant investment. The real advances, like quantum memory and optimization contracts, come from careful experimentation and collaboration. The challenges are substantial, but experts are candid about the hurdles ahead. Quantum computers will likely complement, not replace, classical machines. For NASA, this means a long-term commitment to research and integration. The journey into the quantum realm, like space exploration, demands vision and resilience. The real story is one of steady progress, pushing the boundaries of what's possible, far more compelling than any fleeting rumor.